Alright, ladies and gentlemen, today we are going to look at systems of equations and systems of inequalities. And today is going to be maybe one of the longer videos, just a heads up on that. And it's going to be especially important for you to pause and rewind if I'm going too fast or if you need to revisit something. So let's review solving systems of equations. You can solve three different ways: substitution and elimination, those are both algebraically, or graphically. Let's first look at substitution. For substitution, you need to solve for one of the variables and plug that into the equation and solve. So it should be set up something like this. Now you can put any equation in this form so that you have a variable solved for it, but when it's already set up like this, it's really nice. So, step one, done. Plug into the other equation and solve. So what we're doing is we are substituting this in for x because it is equal to x. So what you get is 2 times, instead of x, we're putting in 2 minus y. Bring everything else down. So plus 7y equals 9. Solve. Distribute. Combine like terms. So 4, and then negative 2y plus 7y is positive 5y. Again, pause if I'm going too fast. Subtract 4 and divide. So you get y equals 1. And my phrase that I like to say is circle goes to circle. So we will now plug our answer into the first equation and solve. So circle goes to circle. X is equal to 2 minus whatever we got for y, which is 1. 2 minus 1 is 1, so it just so happens that x is also 1. You can write your answer as an ordered pair or as a coordinate, 1, comma, 1. Okay, let's look at elimination. This is where we want to get something to eliminate or for something to cancel out or give us 0. Okay, so we need to have everything lined up. So if you look at this example, all of our x's, y's, equals, and numbers are lined up, so that's good. Now we need to get opposite coefficients. Numbers like 2 and negative 2, 3 and negative 3, 4 and negative 4, so exact opposites. If you don't have opposite coefficients, you need to multiply one or both equations by something in order to get opposites. Now personally, I like to work with smaller numbers, but you can work with the 4 and the 5 or the 3 and the 2. And actually, just for it to be a little bit more visually appealing, I'm going to go ahead and work with the 4 and the 5 this time. I changed my mind. So, I'm going to multiply the top one by 5. That's going to give me 20x minus 15y equals 40. Notice I multiplied all three pieces by 5. Now on the bottom, I'm going to multiply by negative 4. Now why do I do that? Because now I'm going to get negative 20x. So we're going to have opposite coefficients here, 20 and negative 20. Then we have plus 8y equals 44. Now that you have opposite coefficients, you can add straight down. The x's give you 0 because 20 and negative 20 is 0. That means they have eliminated. So then you have negative 15 plus 8, which is negative 7y, equals 40 plus 44 is 84. Divide by negative 7, you get negative 12, I believe. So now it says plug back in and solve. You can plug y equals 12 into either of your original equations. I'm just going to pick the top one. So we have 4x minus 3 times whatever y is. Y is negative 12 equals 8. Make sure that you multiply first. So negative 3 times negative 12 is positive 36. You want to get x by itself, so we're going to subtract 36 from both sides. And we're going to get negative 28. Divide and you get negative 7. Again, you can write your answer as an ordered pair or as a coordinate, negative 7 comma negative 12. That's where these two lines would intersect if you were to graph them. So, let's move on to graphing. Graphically, it says graph both lines on the same coordinate plane. the intersection point is the solution. So the first one is in slope-intercept form already, so that's nice. Okay, we're going to plot our y-intercept at 5. Then we're going to use a slope of -4, or -4 over 1. So we're going to go down 4 over 1, down 4 over 1. You can do that all the way across your graph, and in this case, I would encourage you to do it all the way across the graph because it's going to be much easier for you to tell where these lines intersect. Now the second one we actually have to put into slope-intercept form first. So we're going to subtract x from both sides, and we're going to divide by -1. Now, you could have found the x-intercept and y-intercept since it's in standard form, personal, choice or whatever. But in this case now, we have a y-intercept of 10. Looks like we're just about off the graph there. Okay, and then we have a slope of 1, so up 1 over 1. So we would go up and to the right, or we can go back down and to the left, and you see that we have an intersection point there. These graphs intersect at -1, 9. That is the solution to this system. Okay, so you have you have 3 checkpoint problems. So please pause and make sure that you're showing a lot of work for these and input your answer. All right, so now for word problems. We are going to write a system of equations by defining variables, writing 2 equations, and then solving using the method of our choice. So it says tickets for an admission to a high school football game cost $3 for students and $5 for adults. During one game, $2,995 was collected from the sale of 729 tickets. How many students attended the game? So you have 2 totals here. You have 729 tickets. You have a total number of dollars or money. What you don't know is how many students attended the game, or student tickets, and you also don't know the number of adult tickets. So X and Y are going to be number of student tickets or admissions, and Y will be number of adult tickets. We know that a total of 729 tickets were sold. Some of them were students, some of them were adults. We don't know how many of each. That's what we are finding out. We do know that a student ticket costs $3, an adult ticket costs $5, for a total of $2,995. $2,995. I'm not sure if I said that right. So now at this point, you can solve this system by substitution or elimination. I personally prefer elimination, so I'm going to multiply the top one by -3. That will cancel with the +3. So I'm going to get -3x minus 3y equals -2,187. The bottom of the equation is not changed. I'm just going to move it over so that everything is lined up. And I'm going to add straight down. That's going to eliminate these x's because that gives me 0. I get 2y equals 808. So if you divide by 2, you get y equals 404. Now y is the number of adult tickets. That's not what they're actually asking us for. They want the number of student tickets. So we do need to plug that y back in and solve for x. So I'm going to plug it into the easiest equation. X plus y, which is 404, equals 729. I'm going to subtract 404 from both sides, and I get x equals 325 student tickets. You have a checkpoint, so please, again, make sure you're showing your work to find your variables and input your final answer. Solving systems of inequalities. So we are putting in slope-intercept form. Now make sure that when you do that, you are flipping the sign if you multiply or divide by a negative. You're going to graph Okay, and when you do that, you're going to use a solid line for less than or equal to or greater than or equal to. You're going to use a dashed or dotted line for less than or greater than. Shade according to the sign, and there are infinitely many solutions where they overlap. Okay, so when we had a system of equations, there was only one solution, and that was their one intersection point. But now, because of the shading, there will be infinitely many solutions. The first one is in slope-intercept form. We will plot the y-intercept at -2. I'm going to use a slope of -1, so down 1 over 1. When I connect this, I'm going to use a dotted line because it is just greater than, it's not less than, and greater than would shade up. Okay, now the next one is not in slope-intercept form, so we need to subtract 3x over. And we're dividing by -1. Now when you divide by -1, you need to flip your inequality. So we have a y-intercept of 1, a slope of 3, so up 3 over 1. Now when I connect this, because it is a less than or equal to, I'm going to use a solid line. When I shade this, I want to shade less than or equal to. That means I'm shading down. And what you will see is that there is an overlapped area in this dark blue section here. So that means if I wanted a solution to this system of inequalities, I could pick any point in this shaded region. Okay, so numbers like, I don't know, 3, 0, or points like 3, 0, that is a solution. This is a solution. This is a solution. Anything on this solid line is a solution. However, anything on this dotted line is not a solution. Okay? Now, it's a little bit difficult to see just because of the way I kind of connected my dots. It's a little bit difficult to see if 0, 0 is a solution, but 0, 0 really is a solution in here because it's on the right-hand side or in this blue shaded region of the red line. Most of the time, it's much easier to see. So is 0, 0 a solution? The answer in this case is yes. Okay, you have one more checkpoint. Please pay close attention to your slope, pay close attention to if it should be dotted or solid, and the direction it is shaded. Please input your final answer.